Welcome to a new test and teardown video. At first you would think this is a commercial product because it looks so professionally done, but I actually did take off the lid, so I can tell you this is a homebrew equipment. This is a one-off unit and everything is 100% homemade. Look how beautiful it is made on the front. It looks completely like a professional unit, right? And let's look at the back. Look how pro this is. So it's definitely someone who knows how to do stuff. But let's look on the inside. And whoops. And yeah, this is definitely home brew. And everything is just flying leads and trim the values like that. I mean, that is one big chunk of components. So that will be all the LC filters. We also got some resistors and some more resistors. So I don't know. Is this I don't know. The filter here is, it's a high pass filter, right? And filter cut is 50 dB, and that will be all the frequencies. And you also see the cycles, so that tells us this is very, very old. And look at the holes, how they're drilled here in the back. It's a little bit, you know, I don't know. I can't move this knob at all. You see, it's completely stuck. So I need to do my little cleaning trick, and then we will continue the video, I guess. After a lot of cleaning, this switch is working pretty good. See, the input is now 1.8 kilohertz. See, this filter is quite sharp. So see, I put this in the middle, and this is of course high pass filter. So I set it for 630, and let's dial the input frequency. So that was 1800. Every time you hear a click, it's 100 hertz down. So this is 1 kilohertz. 700, 600, 500, and gone it is. So it really works. It looks a little bit funny, but it sure works. So let's have a look in more close detail. I think it's actually both RC and LC in the different sections. So maybe it started as an RC filter, and then they figured out, hey, let's upgrade to LC, and then they made those 3 inductors with all those tappings. So all those tappings together with all those capacitors, super tuned and trimmed, that made all the different frequency steps. And of course there's a nice little attenuator to make up for the loss here. And you saw it was written 36 volts on the back, so that means this thing got a lot of headroom. And yeah, okay, let me just take this off so you can see a little funny detail here. So this is the DC input, and the DC input goes to another red and black So I think you could imagine you could connect more things together on the same 36 volt bus, and then the voltage goes in here to a capacitor, and then two diodes, one diode in the positive and another diode in the negative, and that becomes the power supply for the amplifier. So the two diodes actually give you a little bit of isolation from your power supply from unit to unit. And as far as I can see, this unit is using chassis as signal ground. You can see the mounting screw here, and that black wire goes to the center pin of the DIN connector, and that will be signal ground. That one, and then they connected left and right together as the input and the output pins. So it's quite compatible with signal cables with a shield. Oh, we got two more transistors down there. Quite a lot of goodies. Yeah, okay. So we got more stages. That is how it's done. An input and an output and I don't know what. But it's quite complex. All the resistors here. See, 2 and 2 resistors in parallel to get you the correct value. Imagine how long it took to figure this out, with all the different inductors and capacitors, and oh, we need another little extra one here, and doing the thingy here with the, oh my gosh. I can't help being a little bit impressed about the look. It really looks like a professional unit on the outside. That was one DIY trick. Thank you very much for watching. Bye.